So we're going to look at regression coefficients as a way of doing some predictive analysis in this section. So regression modeling involves basically taking a data set that has some inputs and some outputs and using basically a straight line representation of that data set in order to do a rough order prediction of what will be needed. So for the problem set for this one is going to be some bicycle rental data, which will give us a temperature, wind, and time data and how many bicycles were rented in that time period. So we can use that data set to then predict in the future, given the temperature, wind, and time, what we think the number of bikes will be needed. And we'll use this to make a web application that someone can use, and they can select various options. The season, the holiday, the time period, the temperature, and it will give us an answer on how many bikes we think we're going to need. So we're going to need the chapter 2 files. It has a solution in it, but we're going to use pieces of this to work through this exercise. So if we click on this link, it'll bring us to a place where we can download the source code. We're going to need this for the rest of the class too. So this will bring us to a GitHub repo, and if you want to clone it, you can. But the easiest thing for what our purposes is to download the zip file and store it where we need it. So I have a folder I have for this. You can put it in any folder you want. And I'm going to download that, and once it's downloaded, we'll unzip it. So once it comes down, I'll extract it all to the same folder. And this has all the files. And what we want is we want to take this chapter 2 file. So I'm going to copy that. And we're going to then make another folder where you can place your the files that we're going to work on. And so you don't have to use my directory structure, but I'm just going to use the same folder I used to do my Hello Jupyter demo, and I'm just going to paste it in here and then open that up with VS Code. And then open up this Jupyter notebook. So Jupyter Notebook is just a combination of Markdown and code. And so this is kind of nice. This is going to walk us through the process of exploring this data set that we're going to be using, and allows us to experiment with the data before we actually make our application so we better understand it. And so here it says that we need to download this data set. And so I'm going to follow this link to the bike sharing data set. And they want us to download it. So let's take a look at the explanation. And here's the bike sharing data set. So I will download that, and I'm going to put it in the same directory that I have my that I'm working in the Visual Studio Code. So now it's here, and I'm going to extract that. I'll extract it to the same folder. And we can see here we have a day CSV, an hour CSV, and a README text. Let's take a look at the README text. So here's the attribution from the group that put this together for us. And it tells us about bike sharing applications, which are basically where you put a bunch of bikes around your city, and people can then use them. And so the question is, how many do you need? And as I say here, bike rental is highly correlated with seasonal settings, weather conditions, precipitation, day of the week, season, hour. So let's see. We have a README, hour CSV, sharing counts aggregated on an hourly basis, and day CSV aggregated on a daily basis. What does that mean? Well, they have, presumably what they have done is they have all the bike rentals, and it's going to show you, this file will show us how many bikes are rented per hour, and this will be aggregated how many bikes per day. So they're not giving us each bike and its time. These have been aggregated. That means that they're not that each piece of data will be number per hour for this first one and number per day for this one. And it kind of makes sense why the number of records goes down with per day, because each one is a bigger chunk of data. And then the license. And so if you use this data set, you're going to want to include, on a website, you're going to want to include this reference. So always good to read the README on a data file. And we can look at this either, if we double click on it, it'll open up in Excel, which should work fine. I'm going to open this one up in Excel. You can also right click and open it up as a text file. Excel makes it a little easier for us to see the data. And the things that, you can see, okay, we have a huge number of lines of data, and I think that's supposed to be instance, but that's just a unique ID for each row of data. The date is in month, day, year, I think. No, it must be day, month, year, because we don't have 25 months. So these are kind of things that you want to look at when you're looking at your data is, what is the format of this? Okay, so this is the day, month, year, and then the season one, and let's see, do we have any zeros in here? 1, 2, 3, 4. Okay, so we know that that's one based. One is, and then we have the year, month, and let's see, what are they doing with that year? Month, holiday. Okay, so that's the month of, okay, so they broke this out. And then is it a weekday, or which week, what the week of the day is? It looks like this could almost be Python time format. whether this is obviously a true or false, whether it's a working day, and then the weather. Well, I'll have to figure out what that means. One, it looks like its values 1 and 2, 1 through 3, and the temperature. I wonder if that's air temperature. So when you do your data, try to use more just descriptive terms here. I wonder what that is. And then we have, this is obviously the count of rentals, I guess. I'm guessing 6, 7, 8, 9, 5, 6, 7, 8, 5. Okay, so these two plus equals that. I'm guessing that this is people just walking up and grabbing a bike, and this is someone actually registering it for a bike on the system. And we'll notice that these two add to each other. And then this is the wind speed. And we notice that these factors look like they're between 0 and 1. So let's see if we can get more information in. I'm not going to save because I don't want to mess up the data set. Let's see if what they tell us. So here's, so instant is the record index, the date, season, and then you can see here we're getting a convenient, we're getting the metadata for this data set. Spring, summer, fall, and winter. Year 0 is 2011, 1 is 2012. So, I mean, we could have looked this up, but this gives us, they translated this for us. Month is 1 through 12. Okay. And it's important to look to see if things are 0-based or 1-based. So the month is 1-based. The hours 0 through 23. That kind of makes sense. Holiday, whether the day is a holiday, that's a true or false. The day of the week. Working day, if day is neither a weekend or a holiday, is 1. Otherwise, it's 0. So 1 means it's a working day, just as it says, a true or false, basically. And whether sit, okay, so this is the translation code. It's 1's based, and basically it's good. It's, good for biking to not good for biking from 1 to 4. And then we have our temperature and normalized temperature. So normalized basically means it's been normalized between a value of 0 and 1. And you're going to find, I think, in machine learning applications that this is often done. They find the min and max values, and then what they do is they create a value between 0 and 1 which relates to that. So 1 would correspond to a maximum temperature of 39 degrees Celsius, presumably. I don't think that it would be Fahrenheit. Celsius. And -8 is -8 degrees. So that's the min. That would be a 0. And then 1 would correspond to this. And the values will be spread between 0 and 1, I believe. If we look at our data set again, let's look at the day one. The hour one's going to be very similar, but it's just day one's going to have shorter period, so it's a little easier. So we can see, do we have any negative values, or is the lowest value 0? It looks like the lowest value, I don't see any negative numbers, so it looks like 0 will be the min value here, the way they set up this data set. And then we see here, so T minus T min divided by T max T min. Okay, and so it looks like what they've done is, okay, normalized temperature in Celsius, normalized feeling temperature. Okay, so this is basically the wind speed value. if you're familiar with temperatures, there's the actual temperature, and then based on the winds, what the temperature actually feels like. So this is wind speed adjusted temperature, and then humidity. Values are divided to 100. Okay, and then we've got the wind speed. That was actually what's affecting temperature to change this, and then, which is kind of interesting, because if we were to throw this in a learning algorithm, that it might, I wonder if this would overrepresent wind speed in the solution. It should, normally those things should adjust for it, I think, but just an interesting, because temperature adjusted by wind speed gives you this wind speed. And then count of casual users and count of registered users. That the casual users, I believe, are ones that just walk up and grab a bike that's there, and then the registered users are people that actually reserve a bike, and then count of total bike rentals. So that's our data set, and it's important to understand your data set when you use it. And let's go back up to this directory, and then usually when you find a data set online, you're also going to get a data set description. And so let's look at this. This is usually a PDF document or some kind of text document. If I can get this to go. Okay, so I think this is actually just referred back to this. And okay, yes. So here we have also the same thing that we just looked at on the notebook. It's the data description. So anytime you find a data set online, there's usually two things included: the actual data and then a data description, and that's this document. So make sure you download both of those things and place them place them in a single folder. Once you do that, you can delete the zip file, or you can keep it there if you want to just have it as a backup. But we really need this Chapter 2 Jupyter Notebook and this bike data set available, I believe.